Hey everyone, this is Dave McDonald from Last Pixel. Just going to be going through a little bit of an overview of how I've managed to get a couple of things running with nDisplay, specifically with the in-camera frustum stuff. So for this video, I'm going to assume that you've run the BenKid example, and I'll link that below. And I assume you've also been playing with Vitalii Boiko's setup files, and I will link to where you can find those as well. So I'll just jump into Unreal. So this is basically Vitalii's scene, and I've made a few minor modifications, just in a couple of things with some code and stuff like that, just for my original test setup. So the first thing I'll probably should do is maybe explain what is actually happening. Now I don't know if I can actually make those icons bigger over there. I cannot, so I may or may not have to post zoom in on this. So there's a couple of things set up in the scene that actually make this go. And the main things we're going to need is a display cluster root actor. So nDisplay knows to actually do something. And then the other main things for the in-camera frustum stuff to go is the in-camera settings and the in-camera stage settings. So those two in particular are ones that actually are kind of in the install directory of UE4. And we can find that if I actually go browse to asset, you can see it's actually in nDisplay content. So it's basically all the way down in here and stuff that's installed. If you change these, any code in these, which you may or may not have to, it means it's not actually in your project, it's actually in the install directory. So you need to make sure to be able to, that you're able to copy those out and put those, redeploy them to other machines. So just don't get caught out by that little trap, wondering why it's not running on multiple machines. But what you've really got going on here is a couple of things. So this one is setting up a bunch of things, mainly presets for how you want to do a bunch of stuff. Now, I haven't touched a lot of these. This is stuff for like how the chroma key stuff is working. You know, there's a bunch of different blur stuff in there. And then there's these hidden layers of things you don't want to render on the scene. And there's a light cards actor and a chroma key actor layer. And those are things that are just saying, don't render this. And then there's another layer for when your cards are. I typically haven't been touching this one at all. But if you go into BP camera settings, so there's a couple of things going on here. It's specifying a render to text to viewport ID name. So it's just a name. It's just making up basically a variable name for what we're going to be calling our little frustum render. That will be turning up on screen. The main thing is which cinema camera actor are we picking? So this thing here is just actually asking us to pick in the scene which camera are we going to try and render from. Now, by default, this camera is not doing anything. This could be doing whatever you want it to, but it's not got any preset way of moving it around. That seems to be the things people have problems with, is how are we going to drive this camera to track, in most people's case, the Vive tracker or whatever tracker you've got coming in. None of that is set up for you in the default setting. It's just saying we have this stage, and we're going to, render to a texture, and we're going to be rendering from this actor. The other thing we've actually got going on in this scene is I actually have a mesh monitor, and I'll turn on my, oops, I can't actually hide, I'll hide, if I hit game view that will turn off. So what I've actually got here is I've defined two screens. Just with meshes, they're sort of measured to what my monitors are. Just going to slow this camera down so I can actually get in a little bit closer. So these effectively are what my monitors are, and that's where I want my nDisplay stuff to turn up on those. Now, we'll have to jump back and forth to some config files and show how that's working. But if I open up this, you can see I've just made some meshes. I've actually made them on an angle because my monitors sit angled on my desk, and I've measured it all from a point on my desk as an origin where I put a piece of tape and I measured my stuff from there. And that will come in important later, because we're going to have to recalibrate this origin point against the origin point our Vive is making from its VR setup. Now, the reason I don't do it from the Vive setup area is because every time I have to reconfigure my room or move my lighthouses or any of that sort of stuff, that might move, and I don't really want to move this around. So I've got it measured from there. Now, I do make a little bit of a departure here from Vitali's setup in that he actually has a root node there as well, and he has everything be a child of that. And if we come into the code, you can see it's actually specified to say, which mesh component is the plane. So one of the planes is basically being put into this assign mesh to viewport. We're giving it a string like name of VP_1. We will use that in the config to tell it which screen we're using. And it's saying, what is my root component? You don't need to have this root component if all your measurements are right and you don't need to move anything. It's really not going to do much at all. But where it can come in is, and this is where I got a little bit confused to begin with, if this is all a child of that root and I move that root around and these move with it, nothing has changed about the hierarchy. They're still the same distances from each other. What this cares about, what the meshes are really trying to ask is, how far am I away and in which direction, along which vector, am I from a root origin? What I'm using it for is a recalibration. So if my spot on my desk is there, but my spot in my room where my Vive is probably over here, I'm actually using it to create an offset of that distance, right? So, and I'll try and explain this again. I want to I'll just undo that until I can get it back. In fact, let's just zero it out there. I know my Vive room root is all the way down here. So I need to find out subtracting that vector. And how I'll do that later on is when I move the Vive through the world, I'll put it on my desk, I'll hit a button, it'll figure out the distance it's traveled, and then at runtime, it's going to move this root all the way back to there. And so then, as far as everything's concerned in nDisplay when it's running, these screens are that far from that root. It's probably not the only way to do this, and it's maybe not the best way to do it. You can do it by making another child off this and moving those screens up. I just found this an easy way to do it. It's probably a little bit back to front, but it seemed to work for me. So diving back into here, when we begin play, we're going to go through those two meshes. We're going to assign a mesh to a particular string name that's going to be used in the configs that we will load up in nDisplay. And then I just have this other event called change root offset. I'm negating the vector because I'm subtracting it. I'm saying from the root's position, whatever variable I get back in there. So it's going to actually set the relative location of this root to that position. Now, I'm sending an event to this actor in another piece of code somewhere else, and one of the other bits that live in our scene. So with what's going on with this setup, it is very modular. There's lots of different pieces. In Ben Kid's example, we kind of had everything just living on one root actor, and that's kind of fine. This is so all of these things can be used in different ways, mixed and matched, so you can get them to run. So as we'll just go back into the warp monitor, as you can see, this doesn't know anything else about any of those other objects. All it knows is it's saying, hey, using this part of the API, specify these meshes to be those IDs. And so it's just going to be looking for what nDisplay is sending it and saying, you know what, it's going to be sending to nDisplay, I have these items for you. And as long as it finds those in a config, it's going to go away and do all that sort of stuff. Same with origin view, it's just setting a whole bunch. It's doing a lot of the hard work under the hood, whether it's a texture is being set up. We can dive in and look at, sorry, I think I clicked on the wrong one. Sorry, in-camera settings. We can dive in and look at this. It is a pretty complicated thing, especially if you're not used to blueprints. You don't need to necessarily understand what's going on here. You shouldn't need to change anything unless you're doing some heavy customizations. But basically, it's the thing that is running through a bunch of functions. At event tick, it's running through a bunch of functions. It's making sure it's got a render to texture. It's syncing some processing. It's capturing a chroma key if you need that. I've never touched any of these yet. I haven't got around to it. I haven't needed it. I've been busy getting the other things working. And then it's basically telling the display cluster projection module to use this render to texture, this camera position, and a field of view multiplier, and it's sending that out and it's projecting it onto the views. And that's really all that is doing. Now, this thing knows which camera we're using. It's doing a bunch of stuff. This changes field of view multiplier is pointing at a couple of things as well. So this is a different module that doesn't live in the presets. This is something that I think Vitalii has made. Now it has another variable as well. It's asking, where are my camera settings? So it's asking where this thing is. And it's doing that because if we open that up, now I have customized some code in there. So by default, actually I added a couple of customizations to this code. So it's a simple example. If you hit the plus on the numpad or the minus on the numpad, it's going to plus or minus a number from the field of view and set the field of view multiplier of this item. So which item? The in-camera item, which is, confusingly enough, this is the BP in-camera setting. So back here, it's saying in here, I'm going to change some values in here and I'm going to send them and change a variable that lives in this. And that's why this object needs to know about that object. So it's really changing them in there. If I jump back into there, the other modifications I made is I had to put a clamp in there. And I just specified a pretty high clamp. It was more about having a lower clamp because if you set the field of view value to lower than 0, the whole thing would crash. So I just put that in as a little bit of sanity stuff. And I sort of have, similar to Ben Kidd's example, a frustum offset. So that's what I was doing with that little root offset. So if you hit T, it's getting the display cluster. This cast to, if you actually do that as, I think if you do this object as an interface and not what I have, you can go straight into that. But it needed to cast to transport through. That was probably a misunderstanding on my behalf at the time, but it works. So I'm getting the VRPN tracker location of, and I probably should zoom in. That's as much as it'll let me zoom in. Hopefully this comes out with the res. So I'm setting it to the same device ID of what my Vive is set to in my config file. And from there, we're basically getting that BP warp monitor class, and I'm changing the root offset. So just before where I showed you I made a little function, I'm actually telling that event to trigger in this other actor. So basically this field of view multiplier is doing some changes, and then it's saying, hey, go trigger something to happen inside this warp monitor, which was this thing, which was reset my location. So this is how a little bit of some fairly basic and not necessarily the best way to do it, blueprint communication between stuff. So that's not doing any of the camera movement yet, but the whole idea is to get the tracker to move this camera. So you could do that in any blueprint, and I did have a different blueprint actor that effectively I ask the in-camera settings, hey, which cinema camera do you have? So I don't have to grab it twice. I'm asking this guy, and I'm saying, where is my what cinema camera actor do you have? And then do updates in it. Now I was doing that in a different actor, but what I found, it seemed to work fine, but I think I had problems once I moved to doing it with two machines. It didn't seem to replicate that across the machines very well. It may have worked doing some other things, I'm not sure, but I moved it back to how I was doing it with the Ben Kidd stuff, which was doing a lot of that logic in a display cluster root actor. So this just started its life as a standard display cluster root actor, and then once you edit and make a blueprint, it will, creates you a custom one. So inside there, what I'm doing is I'm saying on event begin play, get actor of class. Now what this thing will do, this will get, the tooltip says exactly what it does. It will find the first actor in the world of that class. So it says it's a slow operation, so don't do it every frame. Don't do it on tick. That's why I just do it on begin play. So I'm saying find me in camera settings, and then find from in camera settings, get me the variable, and we should just be able to do this by here, is a reprojected cine camera. So it's looking at that object because it is context sensitive, but it knows because it's coming out as the right class. Now, sometimes you get yourself stitched up in Unreal because you can't find the thing you thought you were looking for. So you can turn this off and you'll just get a lot more options that maybe hit in this RPR string that I've put in there. So you need to be a little bit careful, and sometimes you need to convert through one thing and through another thing. Like you need to get the object and then the component and a whole bunch of other things. We won't go into that in this video, A, because I'm not a huge expert and I have to kind of relearn that every time I do it, B, it'll probably just get you more confused. But all we're saying is go to this BP in camera settings and get me that variable. So now that I've got that variable, I'm just doing a little bit of niceness here and just checking, is it a valid object? And if it is, I'm setting a variable in here. So I've made my own variable here, which holds the class Cine Camera Actor. Now, it's very important you make it be the same type of variable. It won't let you put things into something that they're not. And maybe I potentially did promote to variable here to create that. It will just give me another one of those. Up here, I changed the name. And it's just there. And I'm going to delete that. It's made me a new one over here. I'll delete that for niceness. And then I just put a little print string in from when I was first debugging this to say, hey, it actually did that thing. It won't get past this stage of this for this is valid and tell me that. So if it couldn't find this object, it would end up, it wouldn't tell me anything. And if it was not valid, I could put another print statement there to just say, I couldn't find anything, you've got a problem. This stuff here doesn't do anything. That's just leftover stuff from me doing some other things. So then after that, it's very similar to what's going on in the Ben Kid example. In Ben Kid's example, we were on event tick, getting the display cluster module API, and then we were getting the tracker location, right? So we're asking nDisplay, that tracker we've identified as this tracker, where is it? And so I'm doing two things. I'm getting the location and the rotation. Now, previously we were just getting the location in Ben Kid's example, and we were setting a nDisplay default camera to be that position. That thing still exists in our example, and that is what we've got as our stage camera. So that's the thing setting up the static views of the whole stage. That still exists. We're not trying to update that by default. We're not trying to control that. We're trying to control our projected camera. So what I'm doing is that variable we made before, which was the CineCam, we're just setting that relative location and relative rotation based off these two. So if I just move this out here, you can it makes it a little bit weird, but you can see where these things flow to. There's nicer ways to arrange this. So we get the VRP tracker location, and we set the actor of the camera relative location. We get the rotation of the VRPN. It has to be converted from the rotation that comes out of here as a quaternion into a rotator because the set actor relative rotation requires that. Now this happens by default. If you just drag that to there, it just makes that. There's not really a big deal about that. So that all is how we are doing the basic camera projection, just attaching our camera to that. Now, I will jump back to this level for the moment. So the other thing we have as part of this puzzle is the LED stage origin view. Now, all this is just saying my default camera that I want to draw the stage onto the screens from, where should that be? If you leave that at 0, 0, you're going to get a weird projection that looks like it's happening on all the walls from the floor. So you kind of want this somewhere meaningful. So if you're standing and everyone else is standing on the stage, it kind of works and lines up. Now, I haven't in this example done it, but say you kind of, in theory, if you're going to work with the whole stage, you kind of want to move this thing around based on where your camera shots are going to be. And that's just so when the camera moves around that spot, you've actually got a spot where the stage makes sense for your other reflections to work around. Now, there's nothing in here changing the code of where this is, but you could make, and I have done in another example I'll show later, I've made a bit that moves this, pops this to new locations around the camera. And I've also made a toggle in another scene that updates the whole stage, just like in the Ben Kit example, as well as doing the reprojected camera, just that there might be examples where you want the whole stage to still move. All right, so what I will do now is I will actually run this, and then I will break down the config file that shows what I run. Now, I kind of am running something that doesn't make sense if you've looked at the Ben Kit view. I'm not trying to pretend my monitor is a window to another world. I'm kind of doing more of a debug layout where I'm putting all of my windows in the one view, including showing the render to texture, so I can see all the things and how they work. So what I will do is go back to my display launcher. So you can see with all this, I have SteamVR running, I have my display listener running, I have my VRPN Open VR things streaming through, and I also have my display launcher. I will make sure I'm definitely selected something there. Now I have the right config for showing this, I believe, which I have as one node, one window, and two views. So we'll hit run. Okay, so you can see I'm actually moving it with the mouse. It doesn't make a lot of sense. I've got weird projections going on because I haven't offset my world as I was talking about. Now, I'm actually also haven't got my Vive controller turned on. I'm going to turn that on. Yes, so now we can actually see I'm moving my controller around and I'm actually getting that bottom view rotating. The top view doesn't make any sense because that's just the stage projection. Now, I'm actually going to run through the offset protocol that I was talking about. I have a spot on my desk where if I put the controller and I hit T, I've now moved effectively both my projection and my stage origin to that point. So they kind of line up. Now you'll see there's a seam between what the projection view is and the other view, and that's just because my mesh in the world had a deliberate seam because this is intended to be across two monitors that actually have a gap between them. But I'm just laying them out on this screen. And if you do this for an LED wall, you can make one big window like this and then use your processor layer between nDisplay and the wall to actually split them up for you. And we do that on our wall. We render out a 4K signal from each machine, and we're currently doing it almost identical to this. We have two screens in the top part of a 4K config, and the bottom bit is just our debug of what the projection is. In Vitali's example, he's pretty much pushing the projection render to texture that I have in the bottom left. He's pushing that off screen so you just don't see it because he's taking up the whole canvas with the actual views. But that is a really good way to debug if you're actually getting stuff right, because sometimes you might have a room config error and you might actually have a projection working, but it's pointing off somewhere well away from your stage. You can see I'm pointing completely the opposite direction and nothing is updating on my walls because that camera is just not casting out that wall. And if I spin it completely back around, the projection comes back in, and I can change my field of view down and you can see that updating within there. So I guess we should dive into the configs and just check how I'm laying this out and what I'm doing. I'm not doing anything particularly special, but it might actually help a few people with the issues that they've been having. So I might escape out of that. Or one thing I will actually point out is for any key commands to actually work within this window, you need to have focus to it. And oftentimes when you'll boot up an nDisplay thing, it will show up on the monitor and look like it's fine and you can get this projection working, but none of your keys work because it's not actually the foreground app. So often you have to tab to it if you've kind of gone in through having other apps open or clicked on. There's potentially a really simple and easy way to make sure that is always the focused app that I don't know about. But just be aware that that's the thing. Sometimes you're thinking you're not being able to get input and things aren't working. When they are, you're just not talking to that app. So I'll escape out of that. All right, so here's my config file. I'll try and make it full screen and I'll actually zoom in a little bit. So I'll zoom in a bit more. I'll just use scrolling to get there. So I have a couple of things commented out because these are just from when I have two machines connected and working. They are not relevant to what we're doing here. So the first thing in here, I'm just running one machine. It has an ID, node 1. It's got one window. This master needs that, definitely. You need at least one master. It doesn't have to draw its own window, but it needs to be something needs to be a master to run and control things. So then I'm specifying one window. So window 1, it has 3 viewports. It has rendered to texture inner. It has VP1, VP2. All this is really kind of neither here nor there. This is its Windows X position across all of your windows. So if you have 2 monitors and you want it to turn up on the other monitor, you would find the resolution point of wherever your 0 point is of your primary display monitor. So monitor 2 can still be your primary display monitor, and its 0 point is its top left. So if you want it to be on the next monitor to your right, you could put 1920 here or whatever. It's just going to push it over kind of in Windows space. We're specifying a res, and then again this second line is redundant, but then we've said that it has 3 viewports, right? So this is where we're specifying our viewports. We've got viewport 1, viewport 2, and then renders to texture inner. And this was the same this has to be the same variable name as is specified in camera settings in Unreal Engine. Now all I've done here is I've said starting from 0, 0. Now this is a little bit tricky. This isn't 0, 0 of Windows desktops. This is 0, 0 of the resolution we're specifying here. So you can actually push stuff out of the resolution of the window we've said here. If you say this is starting at 1920, right? It's actually 1920 plus wherever this starts. So you will end up with a black screen if you push this outside the res of the window. Now in this case, I'm actually just saying you're 960 by 480. I'm specifying a projection name so I can reference it down later. And there's this buffer ratio thing, which can just be something we can use to vary the resolution of these views compared to the render to texture to potentially save on render time, memory, etc., etc. We're doing the same thing with the other window, except this time I'm saying you're halfway across my 1080 screen, or my 1920 by 1080 screen, and you are the same res. So that's how I get two windows drawing at the top of my window. And then I'm actually just saying the render to texture is from an X direction at 0, but it's down 480. So it's down half the height of what I'm actually going to be drawing. And again, it's 960 by 480. And this one is using projection in camera, and it's rendered to texture true. And again, so we come down here, the projections are specified. Those two are meshes, projection warp 1. And the other projection is my projection in camera type camera. Now these are all these IDs are just variable names. They're not reserved things in terms of nDisplay. All that matters is that these things are consistent to what you want them to be, where you've specified what thing belongs in them. So as long as you're consistent with those and you check them, that should be fine. Now, to be honest, a lot of this is probably redundant. Some of the stuff I probably inherited out of my Ben Kit example. The main thing is we're just specifying a camera. This will be by default it will be taken over. It will be hijacked by nDisplay to make its default camera in the way that it wants. It's basically going to chuck one in the world, kind of at your display cluster root. It's being hijacked then in Unreal to actually say, hey, be where my stage offset node is. And then the other thing mainly to check is to make sure this is the same device you are referencing inside your UE4, your blueprint. Wherever you're updating your camera position, this is the thing you need to make sure the name is the same. And then the other thing to make sure is whether it's a type tracker. I think that type is reserved. You do want that to be a tracker, that's fine. The address, if you remember in the Ben Kid example, sometimes you might have a tracker that needs to say it's a controller here because that's what its address is. And sometimes you might need to say it's the other way around. I don't have any trackers yet, so I haven't tested that. This device number basically is going to be the thing that streams past in your VRPN server. So that's your devices. And those are the hardware addresses of your devices. They're not going to be compatible against different Vive controllers if you change systems. It has to be those. You'll probably have two. It's one or the other. I actually sometimes have two lines where I have them both done, one commented out, so if battery runs out, I can swap them over. The rest of this stuff, for the purpose of this, we're not really using. You can also specify the VRPN device as a type buttons, and that lets you use the click buttons and the axes and stuff from the Vive and send that through to control other stuff. We won't really get into that, but you can do it. And then the rest is kind of the same. If you're loading up a pretty slow scene, sometimes you want to up some of these numbers to wait a little longer. A few problems I've seen people get is where they have it black for a while and nothing happens and it closes, and it's probably because it's hit that timeout. And it might be hitting that timeout for a couple of reasons. It might do it because your scene is a DirectX 11 scene that has never been told it's DirectX 12, and then you specify it to boot up in DirectX 12. And what happens then is behind the scenes, it is going to be compiling all those shaders. So the time, when you load up Unreal and you see the shaders ticking along and going really, really slow, that is going to be happening behind the scenes, and you won't know about it unless you look at the logs. So in the logs, while we speak of that, I've basically turned all of my things to verbose, and the reason I do that is I think by default it tells a lot of things, but I just wanted to make sure. Now those logs are going to live in your project that you boot up, so whatever project you call here, in its saved logs directory. Now we'll just bring that project up, which lives in my directory over here. So if I bring this window over, if I can get it past the window, you can see I have logs here. It's going to show me the last time I ran it. Now this is really, if you're having issues, looking in this log is really going to be your best friend. It might not exactly tell you anything 100% too meaningful. And my machine is going really rather slow for some reason. We killed nDisplay, but this is not working. All right, so because it's a very long log file and it was 140 odd meg, Notepad was struggling with it while I'm recording, I think. But I've opened it in Sublime Text, and basically it was telling me a lot of stuff, probably more than it normally does. But if you've got crashes, they typically will be down the bottom. Now, this isn't one. I probably should have saved one that actually has a lot of crashes. But if you scroll most of the way to the bottom, this is typically where it's telling you what its exit event has been. Now, this will probably say UE4 soft application quit requested, exit on escape requested. So it's telling me I did that. But often somewhere within about the last 20 or 30 lines is probably where it starts to tell you where things have gone wrong. Or if it had to compile a bunch of shaders, you will see lots of lines going on. Now I might need to turn some of the verbose printing off there now that I have working stuff, because it is probably actually taking up a little bit more than it needs to keep printing stuff in there. So that's the main gist of that. Now we'll go back and just go over a couple of those things. Now, so in the config, we were specifying which of these two views they are. And so they were VP1 and VP2. That's as much as I can zoom in. VP1 and VP2. Now, they're specified there. That's what I want them to look like when they actually displayed some other ways. And the in-camera settings is specifying that render to texture. There is other things in here as well, like whether or not you're showing that frame or just showing the stage. This will turn the render to texture off, and you could make some code that turns that off based on a key press. You just need to tell it to talk to in-camera settings and turn that variable off. It's also got stuff for how much blending you've got around the outside and whether or not it's using the camera post-processing. So if that's on, pretty much any camera post-processing you stick in that cinema camera that's referenced will happen. As far as depth of field goes, it's been a bit fiddly. It doesn't seem to respect this manual focus distance. The value it seems to respect for me lives down here under post-production depth of field. And it seems to be this distance. Now you should be able to then also make code to send to that. I have been getting some strange results where this depth of field gets adjusted based on the field of view multiplier. I will probably post something up if I get to the bottom of why that's happening, but it was just something I noticed the other day and have not fixed yet. And so yeah, that's the main thing. So just back in the display cluster, it is being specified to grab the camera that the in-camera settings knows about, put it in a variable here so I can reuse it, and then similar to Ben Kid, we're just grabbing the data from the VRPN tracker location and rotation, and we're just making that camera stick to it. We're just making it follow along. Now what I will do is I'm going to close this one and I'll show you what is going on in a more in-depth scene. I will close that project as well, and I will not save. I'm going to I'll open the project and then I will run it in the window as well so you can see that. So I have burned forest. Get all this out of the way. So after a few minutes of my poor little laptop struggling through opening this scene while it's also trying to record, this is a scene I have which I used in the SimTrav example, which many of you may have seen. Now this in front of us is basically the 3D representation of my LED wall I've been working with. Now it basically just has a texture map of a screen capture just so I could test that my UVs worked. So this is effectively my mesh actor that is telling nDisplay what my walls are doing and how the reprojection should work. Now I'll just grab that. This is a BP Warp Multi monitor again, and we're just going to open that up and you can see how I specified that. It's not anything different than what was going on in the other one, other than it's just bigger and measured to scale. I can probably do unlit, that doesn't really matter. Wireframe, it's a very simple wireframe mesh. It's basically defining each panel width based on the stuff I've got. And yeah, and then in the event graph, it is really simple. It is just saying each one of these, I have a curve A, B, C, and D, and I'm just giving them an ID. I'm giving them A, B, C, and D. And then I have a specific config for this project which references those as the viewports I want to draw. There's not really much going on other than that. Everything else is pretty similar. I've been hijacking stuff in the BP change field of view. I've been using this as the place I'm changing a bunch of stuff. I have two choices. I can either do it in display cluster root actor and have the inputs I've specifically got, but a lot of them I've actually put in the field of view multiplier. Yep, so coming into here, first thing I'm doing is disabling all screen messages. This by default I think already had get input from the player controller. This just lets it receive keyboard commands and stuff like that. So the reason plus and minus works is we're specifying this. You can inside the level say get input from a specific player, but this is potentially the easier way to do it because no matter who is, well, it is always getting the player 0, so it's probably moot. But you can also just specify here in code. Now what I'm actually doing is I'm going and getting the mesh wall, and I'm getting the first one of those, assuming I only ever have one. I can't see how you would have multiple actors. Maybe that's the thing down the line. I need to do some bug testing around. I'm making sure I can get it, and I'm putting in a variable called mesh wall. I'm going to use that later on. The other thing I'm doing is, as always, getting the display cluster module. Then what I'm actually doing is I'm getting the local viewports, and I'm saving them in an array called views, and I'm using that later to be able to cycle through and set the post-processing on all of the walls and just have which ones they are, so I can call that. The field of view offset is the same as what Vitalii had. I still have a T position reset doing exactly what I said in the last one and changing that root offset. It's potentially redundant with some other changes I've been doing on my stage. What I have done as well, so this is where I've done something tricky and there's other ways to do it. Sometimes though, because you're using a VR headset to create an alignment of your world, effectively with nDisplay, we're trying to say we know we have an accurate representation of where our origin of the world is and which way it faces. And we're using a very blunt instrument, which is a VR headset, and pointing it in a direction and just saying, you're there. And that actually might be out. And no matter what you do, it's going to be really hard to calibrate that correctly. So where you were facing the headset, that's going to be your X forward direction. And if I actually just go back for a second and open my warp monitor, we are actually assuming, if I go to the top view, that this forward X direction is going to match that exact point. And if the headset is out by a couple of degrees, all of a sudden everything else here is not going to project correctly. So I've made myself a little feather to manually offset that until it looks better. Now I have two options. I could have inverse rotated that root, as I showed you the inverse movement previously, or I could make another null that I rotate the mesh around. And it's all about changing the relationship of the mesh to the root. Now I've just made that go, and I'm just setting a relative rotation. And that actually helps me feather in the projection to make sure it actually works nicely. And then I actually have a bunch of stuff which changes post-process settings. I probably won't go into that too deeply, because it is actually work in progress code. Those are the main things that are going. Everything else is basically the same. I just have a bigger mesh in here, and I have some custom changes in the field of view multiplier. I have some other experimental modular nodes I've been playing with to actually do things like listen for OSC commands and actual cluster events, not currently used. But what I will do is go back to my nDisplay launcher, and I'll load that burnt forest, and I need to change that config to, I think it is one window, two views, and we will run that. All right, so here we are in the scene. I've got mouse control. This scene doesn't work necessarily particularly great on my laptop. And you can see I have the camera view. Now I actually deliberately have a different exposure setting between these two so I can easily see it, and I've changed the feather. And I have buttons to correct that as part of those things I showed you. So what you can see is, and this is not set up to actually position itself against my monitors. We actually have to imagine I've got a giant 27 odd meter wall. Well, half of that. This is a 14 meters of wall. So I'm just pointing my Vive randomly in my room to get it to look around the scene. You can see if I look completely around, it's not actually projecting on the wall, but as long as I project where that space is, I actually have this. Now I can actually do things like we've got pan up and down. That's just on some keys. That's whatever was set as the default input in this one. And we can actually also move through this world. I think I have a fast move hooked to a shift. So this is actually, this is all just by there being a default pawn in the scene. It's just going to bring this along for the ride. Everything is a child of it. The other cameras and stuff and the stage get moved. So it all just moves kind of nicely. And I can't drive the camera and the mouse at the same time. But you can see that just kind of looks, wherever I look, it's kind of all fine. And that actually tracks there. This is a really good way, I think, of debugging your scene. Like I said, this is actually how we use it to project at the moment. But we've also had the whole wall projected as two different slices on 4K from one machine instead of two machines. And then in that case, we just don't show the rendered texture on here down the bottom. I also have a experimental button at the moment that if I click the button on the controller, I'm actually now moving the whole stage as well. So it does stay pinned. It doesn't seem to, affect performance too much. And I just need to create one more button that's going to say, hey, offset my stage position to where I am now. So then if I move relative to that, it's actually closer. Which doesn't make sense in a small setting like this, my room, but when I'm down on the wall and I'm potentially moving tens of meters around, you might get further away from where you actually want everything to look right from. But that's the basic setup of what is going on. Hopefully this has helped a few of you get a little bit of an overview of the changes you need to make and the tweaks you need to make to get things working. And I'll be posting this video up a few places, so it probably won't be a public videos, and it won't turn up on the YouTube channel, but it will turn up as a link and is shareable. Just let me know how you're getting on with it all.